Now we're going to look at a couple examples where we're going to use series to evaluate some limits. So from a previous section, we know that we can rewrite cosine t as a series, and I'm going to do that here in just a moment. For the first one, we're asked to find the limit as t approaches 0 of 1 minus cosine t minus t squared over 2, and then that whole thing over t to the 4th power. So this is equal to the limit as t goes to 0. And I'm going to rewrite things ever so slightly. The divided by t to the 4th, I'm going to write that as a 1 over t to the 4th in front. And then I'm going to rearrange some terms ever so slightly. I'm going to put this negative t squared over 2 just after the 1. So we're going to have 1 minus t squared over 2. And then minus cosine t. Well, cosine t can be represented as a series, and it's going to look like this. It's going to be 1 minus t squared over 2 factorial plus t to the 4th over 4 factorial minus t to the 6th over 6 factorial plus t to the 8th over 8 factorial. And I could keep going, but I'm not going to. But that is cosine t written out as a series. The negative here in front of that series is going to, of course, change all of the signs. So now I have the limit as t approaches 0, 1 over t to the 4th. And we've got 1 minus t squared over 2 minus 1 plus t squared over 2 minus t to the 4th over 4 factorial. Sorry, this should be a 2 factorial. Plus t to the 6th over 6 factorial minus t to the 8th over 8 factorial, and so on. Well, 2 factorial is just 2. So these first 4 terms, the first 2 cancel out the second 2. So these first 4 terms are just 0. So now I have the limit as t approaches infinity of 1 over t to the 4th times the rest of this. Well, now that 1 over t to the 4th is going to come into play. I'm going to go ahead and distribute this. And when I do, it leaves me with the limit as t approaches 0 of negative 1 over 4 factorial plus t squared over 6 factorial minus t to the 8th, or sorry, let's try that again, minus t to the 4th over 8 factorial, and so on. So as you take the limit as t goes to 0, except for that first term, everything else is going to go to 0. So you're left with just negative 1 over 4 factorial, which is negative 1/24. And there's your limit. So let's do one more. The second one is the limit as x goes to infinity of x squared times e to the negative 1 over x squared minus 1. Now, from a previous section, we know that e to the x is the sum from n equals 0 to infinity of x, excuse me, x to the n over n factorial. Here, we do not just have an e to the x, we have e to the negative 1 over x squared. So we're going to have something that looks a little different. E to the negative 1 over x squared. Instead of an x, we've got this whole term here, will be the series that goes from n equals 0 to infinity of negative 1 over x squared to the n power over n factorial. And you could rewrite this as the sum from n equals 0 to infinity of negative 1 to the n power over x to the 2n times n factorial. So we're going to use this. If you were to write this out, so starting with n equals 0, you're going to have 1 minus 1 over x squared plus 1 over x to the 4th times 2 factorial minus 1 over x to the 6th times 3 factorial, and so on. So now let's go back to our limit. And I'll actually switch to a different color here. There we go. So we have the limit as x approaches infinity of x squared times. So we have this series minus 1. So we have 1 minus 1 over x squared plus 1 over x to the 4th times 2 factorial minus 1 over x to the 6th times 3 factorial, and so on. Minus 1, don't forget that minus 1. So of course, the 1 here in the front and the negative 1 all the way here at the right are going to cancel out. So leaving us with the terms with the x's. If I then distribute the x squared, here I can go ahead and get rid of these. If I distribute the x squared, we're going to be left with the limit as x goes to infinity of negative 1 plus 1 over x squared times 2 factorial minus 1 over x to the 4th times 3 factorial, and so on. Well, as x goes to infinity, starting here with the second term, these are all going to go to 0. So we're just left with a limit of negative 1.